We're given a binomial here and we're asked to factor this. So when you're given a binomial and asked to factor it, especially if it's a complex binomial like this, where you've got three different variables in here, the first thing that you should do, especially if this is a minus sign, is look to see if the two terms are perfect squares. Because if they are, then that's going to save us a lot of work and we can just use something called the difference of squares. And so if I look at the first term, this is a perfect square. This, if you take the square root of this, you would get 4x y to the second. I look at the next one, it's also a perfect square. The square root would be 5z to the third. So when you have that, let me write down what difference of squares looks like. So difference of squares, I'm just going to write diff to save you some time, not having to watch me write, which is not fun. Difference of squares looks like this. It's a squared minus b squared equals a plus b times a minus b. And the way you get the a and the b values is by simply, so the way I get these two values is by taking the square root of each of these. So I told you these are perfect squares, so we'll just take the square root of each of them, and the result we'll put in this form. All right? So let me just right below this, I'll write our binomial. So I have 16x squared y to the fourth minus 25z to the sixth, 25z to the sixth. And so that would be equivalent to, let's go ahead and, we know it's going to be in this format with one of them's a plus and one of them's a minus. And so I said the square root of 16 is 4. The square root of x squared is x, and the square root of y to the fourth is y to the second. And then I have the square root of 25 is 5, and the square root of z to the sixth is z to the third. And then I just write the same thing over here. So 4xy squared minus 5z to the third, and that's going to be my answer. And so if we check, that is the answer for. Now, one quick thing I want to point out to you just as a reminder. So when you're taking the square root of a number, so like 16, for instance, is saying what number times itself is 4. Now, what about when there's an exponent? Well, it's asking the same question. It's saying what times itself is z to the sixth, and the answer is z to the third. Because remember, I'll write this down for you. So remember, when you multiply powers, z to the third times z to the third, you add the exponents and you get z to the sixth. So really, when you're doing a square root with exponents, you're just taking half of that value. And any exponent that's even will be a perfect square. That's how you can tell with an exponent if they're perfect squares. And you can see all of these exponents were even. And so then when I take the square root of them, I just divided them by 2. And that's where I got x and I got y to the second. So I did 4 divided by 2, and the 6 divided by 2 gave me the 3. All right. So difference of squares is really useful. I would encourage you to memorize this. And again, you just look for a binomial where both the terms are perfect squares and they have to be being subtracted for this to work. All right. Keep up the good work. You will master the math.